Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write the molecular, complete ionic, and net ionic equations for zinc acetate reacting with lithium chromate. So let's get into this. So first thing you want to notice is that they're giving us the names of the compounds and not the formulas. So we need to go from the name to the formula, and if you are struggling with that or you need a refresher, please see my video on naming ionic compounds where I go over that. But I'm going to go over it a little bit today in this video. So we need to know that the name of the ionic substance is actually the name of the ions put together. So the name here tells you the name of the ions. So we have here the zinc ion and the acetate ion. So zinc ion is just Zn, and here zinc, we have to realize what the charge on zinc is. And zinc has a charge of a 2 plus. Normally we would think that it depends on the product, or it depends on the compound that zinc is in, but because zinc is a transition metal, but it's one of those special exceptions where zinc usually only has the one charge of a 2 plus. So we don't need a Roman numeral. So notice there's no Roman numeral in the name, even though this is a transition element. So because it only ever has that one charge. So that is going to be a zinc 2 plus ion. So there we go. And the acetate is a polyatomic ion. So you need to know your polyatomic ions. And I'm sure your teacher gave you some sort of list to memorize. So make sure you memorize that list. If you need help looking at patterns, I have a video on polyatomic ions where I go over patterns to help you remember what those formulas and charges are on the polyatomic ions. But for acetate, you need to know that the acetate ion is C2 H3O2, and it has a minus charge there. And so once you have the ions, now you can know how to put them together. And when you make a formula of these, you need to balance the charge. So here we see that we have a -1 charge and we have a 2 plus charge. So I'm going to need 2 acetate ions to balance the charge of the zinc. Another way you could do this is use the crisscross method. So the crisscross method is you take the numbers and you crisscross them as subscripts. You put them as subscripts, so they're subscripts, and there's a 1 here, so that goes there. We don't write the ones, so this is going to be zinc, and then we have a 2 acetate. So we're going to put parentheses C2H3O2, and we're going to put a 2 on the outside. So you'll notice that whenever we have more than one polyatomic ion, you need to use the parentheses and have the number outside the parentheses. If you only have one polyatomic ion in your formula, don't use the parentheses. All right, so here's our first formula for zinc acetate. So now we have to do the same thing for lithium. So lithium is Li. It's a group 1 element, so we know it has a plus 1 charge. How do we know it has a plus 1 charge? Because of the rule that if you are in groups 1A, 2A, or 3A, then the rule for that is that charge, the positive charge, is equal to the group number. So since this is in group 1, it's got a plus 1 charge. The better way to remember this is to kind of understand what's going on at the atomic level and to keep in mind the valence electrons. So we know that the group number for your main group elements, 1A through 8A, that group number is equal to the number of valence electrons in your atom. And so keeping that in mind, and also keeping in mind that all the atoms want to be like noble gases, and most of the noble gases have an 8 electrons, valence electrons in their outer shell. All of them have a complete outer shell. That's what they want. So lithium, in order to get that complete outer shell, will lose that 1 electron. And by losing that negative electron, there will be a proton in the nucleus that will no longer have a balanced charge. So that's where the plus comes in. So that's going to be a plus 1. The chromate is, again, another polyatomic ion. So we need to make sure that we know what chromate is. So here chromate is CrO4, and it's got a 2 minus charge on that. So that's the chromate ion. Again, we see we have a 2 minus charge, we have a plus 1 charge. So I'm going to need 2 lithiums to balance the charge. So again, we can also do the crisscross method. So the 2 goes over here, the 1 goes over there. And so I have Li2. Let me write it over here. So I'll add it here. So I have lithium 2, and then I have my chromate, CrO4. And so there are my 2 reactants. So what about my products? So now I'm going to create the products. How do I figure out what the products are? So this is where you have to recognize what kind of reaction we have here. So here I have an ionic substance, and here I have an ionic substance. So whenever you have 2 ionic substances as reactants, that's a dead giveaway that you have a double replacement reaction or a double replacement reaction. So here, in order to figure out the products of a double displacement reaction or a replacement reaction, it's really easy. All you do is you put the inside ions together, and then you put the outside ions together. And that will give you your product. So whenever you put the ions together, you got to make sure you balance the charge for your formula. So here I have zinc, which is a 2 plus charge, and I have chromate, which is a 2 minus charge. So 2 and 2 is equal, so I only need 1 each for the formula. So that's going to be ZnCrO4. So that's my first possible product. And then I put the inside ones. Lithium has a plus 1. Acetate has a minus 1. So again, 1 and 1. So I only need 1 each. So I'll put that down here since I didn't give myself some room. So that's going to be LiC2H3O2. So there are my 2 products. So the next thing I need to do is I need to make sure I balance the equation and then determine what the states of matter are. So let's balance it first. So I have zinc here. I have 1 zinc, 1 zinc. That's balanced. I have 2 lithium, but I only have 1 lithium here. So I'm going to have a 2 coefficient. So I'm going to put the 2 coefficient there. So now I have 2 lithium. I have 2 acetate ions. I now have 2 acetates ion there because I have the 2 coefficient. And then I have chromate. I have 1 chromate ion, 1 chromate ion. This is a balanced equation. So now the last part is figuring out what the states of matter are. And you're going to need some sort of solubility table or solubility rules. I'm sure your teacher gave you one, or you could easily find it on the internet. So using your solubility rules. So we have zinc acetate. So acetate ions are soluble in water. There really are no exceptions. So let's double check on the solubility rules. So it says, on mine, it says all salts of nitrates, nitrites, acetates, oxyhalogen anions are soluble. So there's no exceptions. So this is soluble, so that's aqueous. So this is going to be aqueous. Lithium chromate. So let's look at the rule for lithium chromate. It says on my sheet, chromates. It says that all salts that contain carbonates, phosphates, sulfates, chromates are insoluble except for group 1 elements and ammonium. Let's see if there's any other exceptions. It doesn't look like it. So it looks like chromates are insoluble unless you have a group 1 metal. So here lithium is a group 1 metal, so this is an exception. So this is aqueous. This is soluble, not insoluble. So this is going to be aqueous. And here we have, again, zinc chromate here. So again, chromates are insoluble unless you have a group 1 a metal like here, or ammonium. Zinc is neither one of those, so this is insoluble. This is going to be a solid. This is our precipitate. So that's going to be a solid. And again, we have acetates. All acetates are soluble, so that's aqueous. Okay, so we got our completed balanced equation. So here we have our balanced molecular equation. So now we're going to get our complete ionic equation. And so again, in the complete ionic equation, we want to separate the ions. So anything that is aqueous is actually the ions are not together. So when we write a molecular equation, we're writing our ionic substances together as if they are molecules, but they're not molecules. They are ionic substances, and aqueous means that they dissolved, so the ions are separated from each other. So we're going to do that in our complete ionic equation. So this is aqueous, so we're going to separate out those ions. So I'm going to give myself more space. So zinc has a 2+ charge, and so that's aqueous. And notice that when I write the ions, I am writing the charge for the ions. When we write it in this form here as a molecule or as a formula, then we don't write the charges. So here I have 2 acetates. So I'm going to write the subscript as a coefficient. The reason I don't write this subscript here, I don't keep the subscript because if I keep the subscript down here, then what I'm actually saying is that I have 2 acetate ions that are somehow bonded together, and that's at 1 unit. But that's really not what's going on. We have 2 separate ions floating around in solution. They're not together. So that's why we're writing the 2 as a coefficient. So subscripts become coefficients. So here we have 2 C2H3O2 minus aqueous. So that's that. Now for our second reactant, so we're going to separate these ions because it's aqueous. So again, I have 2 lithium, so that's going to be a coefficient 2 Li plus aqueous plus, and I have my chromate, 1 chromate, CrO4, and that's 2 minus aqueous. So now I've separated all my reactants. So now I'm going to do the products. So the solid, anything that's solid, liquid, or gas does not get separated. So especially if it's an ionic substance or if it's a molecular substance that is dissolved in water, like sugar. So if I have a sugar molecule and it's dissolved in water, that will be aqueous, but I'm not going to separate it into its various atoms. So same thing with this solid here. This means that the ions are actually bonded together in a solid. They are not separated. So I'm going to keep that together. So zinc CrO4 solid stays here. Plus, and then I have this here. So I'm going to separate those. So I have 2 lithium plus ions aqueous plus 2 acetate ions CH3O2 minus aqueous. And so here I have my complete ionic equation. So what you see here is complete ionic equation. And so the way you can understand this is before I mix these together, this is my 1 beaker. So I have 1 beaker. This is my stuff floating around in solution. Here I have a 2nd beaker. This is floating around in solution. So I have my zinc acetate solution where the ions are separated, floating around, doing nothing. Here I have my 2nd beaker of lithium chromate. The ions are floating around, doing nothing. And then what do? I take the 2 beakers, I mix them together into 1 beaker. So here's my 1 beaker. It looks more like an Erlenmeyer flask. But here's my substance. And when I mix them together, the zinc and the chromate ions come together to form a solid, and that causes some cloudiness in your beaker. And so that's what's going on there. These ions are still floating around doing nothing. So when we're writing our complete our net ionic equation, What we want to do is remove the ions that are not doing anything. Those are called our spectator ions. So they're not part of the reaction. So any ions that are not part of the reaction are removed to create our net ionic equation. So there's two ways you can do this. You could look at the products, see what products are formed. If you get a solid, liquid, or gas, then anything that went into that is not going to be a spectator ion. So we're going to keep those. Anything else that's not part of those reactions or that reaction is going to be removed. The other way you go about it is look to see what stays the same on both sides of the equation. If I have something that's aqueous over here and it stays aqueous over here, that is not doing anything. That's going to be a spectator ion. So we remove it. So zinc here is aqueous, but it's here in a solid. So that is not staying the same. So we keep that. That is not a spectator ion. Here we have two acid ions aqueous. Here we have two acetate ions aqueous. Stays the same. That is a spectator ion. So we can remove that. Same thing with lithium. We have two lithium aqueous, two lithium aqueous. So that's a spectator ion. We could get rid of that. Chromate is in the solid, so we're going to keep that. So all we do now is write what's left. So, So we have zinc 2 plus aqueous plus the chromate CrO4 2 minus aqueous, and those are going to come together to form the solid zinc CrO4 solid. And so here is your net ionic equation. I hope this was helpful. If you enjoyed this, if you got a lot out of this and you learned something, please like the video, hit the like button, share the video with others, put a comment in the comment section, let me know what you think, and if you have any other questions. Don't forget to subscribe to my channel, hit the notification button so you'll be notified by other videos I put out. Thanks for joining me. Have a great day.